Factors and Products, Lesson 8, Multiplying Polynomials. We've already done this before, but what we're going to do now is we're going to make it a little bit more spicy. Before what we did was we multiplied binomials by binomials, but now we have binomials by trinomials. So we can use the box method to help us through with this, but ultimately what would be really great is if we could use the distributive property. But this box method does help, and if you prefer using the box method, have at her. That's a-okay. So to do the box method, we're going to put our terms up here. So x squared, and then positive 3x, and then negative 4. And then here we have a 2x, and then here we have a positive 5. And now we just go and we multiply. So 2x times x squared is 2x to the power of 3. 2x times 3x is 6x to the power of 2. 2x times negative 4 is going to be negative 8x. And remember, when we don't have a sign in front, that just means that it's going to be positive. 5 times x squared is 5x squared. 5 times 3x is going to be 15x, and 5 times negative 4 is going to be negative 20. Now what we're going to do is we're going to collect all these like terms. So we're going to say 2x to the power of 3 plus 6x squared minus 8x plus 5x squared plus 15x minus 20. So I know you know how to do this already because I taught you in grade 9, but we're just going to collect the like terms. So x squareds go with x squareds. There's nothing to go with our x to the power of 3, but then we do have negative 8x and positive 15x, and then again that constant is all by its lonesome. So we have, as a result, 2x to the power of 3, 6x squared plus 5x squared is plus 11x squared, negative 8x plus 15x is going to be positive 7x minus 20. And that is our final answer. So the steps, if we wanted to have the steps, take each term in the first polynomial and multiply it through each term in the second. Then you're going to do your collect like terms thing, and then that will be your answer. So this one is a 3 by 3. So if you wanted to use the box method, instead of having a 3 by 2, we would have a 3 by 3. But what I'm going to do is I'm going to demonstrate that distributive method, and I'll use different colors, okay? So we're going to say this negative 3x is going to be distributed to 4x squared, to negative x, and then to negative 6. So when I do this, I'm going to do this one in green. So negative 3x times 4x squared is going to be negative 12x to the power of 3. Negative 3x times negative x is going to be positive 3x squared. And then negative 3x times negative 6 is going to be positive 18x. Okay, I'm going to use a different color now. Red. So I'm going to take this positive 3 and distribute it to the 4x squared, to the negative x, and to the negative 6. Don't worry, I'm going to go from below on the next one. Okay, so positive 3x times 4x squared is going to be, oh, I just realized something. We could have collected these like terms here to make it a little bit easier, but let's just keep on going with it. So we have 3x times 4x squared. So we're going to say plus 4x, plus 12x. I'm getting all discombobulated here. Okay, 12x to the power of 3. And then I'm going to say negative 3x squared. And then I'm going to say negative 3x, positive 3x times negative 6, which is going to be negative 18x. So we just, in all honesty here, look at this. We have just a whole bunch of 0 pairs that are going to cancel. But I digress. We'll get to that in a bit. Now let's take our last term, our -2. So we're going to apply that or distribute that to to positive 4x squared, to negative x, and to -6. So I'm gonna do the good pre-cal thing and try to squish. Nah, I can't actually squish it on one line. So I'm gonna say minus 8x squared plus 2x plus 12. So I'm gonna highlight all the like terms here. I have x to the power of 3, x to the power of 3. I have positive x to the power of 2 minus x to the power of 2, negative 8 to the power of 2, positive 18x, negative 18x, and then 2x. And then I have this all by its lonesome. Whoop. Okay, so when I collect these like terms, negative 12 plus 12 is 0. 3x squared minus 3x squared is 0. Minus 8x squared is going to be negative 8x squared. Now we're going to look at these orange ones. Positive 18 minus 18 plus 2 is going to be positive 2x. Then we just have this 12 all by its lonesome. And that's that. Except that this made it look like a 3. There we go. That's better. That's our answer. Let's tease out this one. So we know that anything to the power of 2 is just multiplied by itself. So I'm going to say 2r plus 4t to the power of 2, which is times 2r plus 4t. Now this one right here is just something that we're comfortable with. That we've seen before, so I'm just gonna demonstrate that distributive property again. So that r squared, that 2r going to both of them, so we have 4r squared plus 8 rt, and then I'm gonna go to the bottom here, 4t times 2r, and 4t times 4t. So I'm going to say plus 8rt plus 16t squared. So when I simplify this right here, I'm going to get 4r squared plus 16rt plus 16t squared. Boom. Done. Okay, so this one right here is a bit of a spicy meatball. It's kind of a two-stepper, so we're gonna have to take it in 2 chunks, and it gets a little bit messy, but we're gonna have to do this 2 times. So we're gonna have to do this here, and we're gonna have to do this here. But we want to make sure that we annotate it using, or write it down using pre-calculus methods. So we're not going to do any side work and then bring it all back together. We're actually going to rewrite every single line that we need to. And I know that sounds